In this video, I'm going to go over the whole entire worksheet that we did not complete in class. All right, so let's go ahead and begin with number 1. X is the incenter of triangle RST. Find the measure of angle TRS. So we are given that point X is the incenter. Therefore, that lets us to conclude that RX, SX, and TX are angle bisectors. And we know they're angle bisectors because angle bisectors are the ones that construct the incenter of a triangle. So since those three segments are angle bisectors, then I can conclude angle congruencies. Okay, I know that angle RSX is congruent to angle TSX. I can also conclude that angle RX is congruent to angle TRX, and that angle RTX is congruent to angle STX. All right, so in order to solve for the measure angle TRS, first thing I need to do is find the value of X. So in order to find the value of X, I need to set up an equation. Since these two angles right here are congruent, therefore, I can set these two expressions equal to each other. So let's go ahead and set those expressions equal to each other. Ooh, there we go. All right, so we have 3x minus 20 equals 2x plus 8. All right, so let's go ahead and solve for x. So in order to solve for x, I'm going to subtract x on both sides in order to leave it on one side. So we have 2x minus 20 equals to 8. Therefore, I'm going to add 20 to both sides because I'm combining like terms. So I have 2x equals to 28. Then the last step is to divide both sides by 2. Okay, and x equals to 14. Now, this is not our final answer because, again, we're asked to find measure angle TRS. So what I'm going to do next is plug in 14 and replace x and plug in 14. So I'm using substitution. So 14 plus 8 gives us 22, and I could have used in that 2 right here. Okay, and that would have not 2, I don't know why I put 2, it should be 14. And this will also give us 22. They should both equal to 22 since the angles are congruent, but I'm only focusing on just angle RSX. All right, so now, next step in order to solve for the measure angle, I'm going to find first angle measure SRX, okay? And I'm going to highlight a triangle that will help us find that angle measure. That's this triangle right here, okay? I know that the sum of all three angles in one triangle is 180. So since I have 2 out of the 3 angles, all I have to do is add the 2 angles, so 133 plus 22 gives us 155. And I'm going to subtract that from 180. And again, 180, since I know that all 3 angles add up to 180. And 180 minus 155, gives us 25. So that means that this measure here is 25. Again, this is not our final answer because that's not angle TRS. However, since this angle right here, SRX, is congruent to angle TRX, then I can conclude that angle TRX is 25. Thus, by angle addition, measure angle TRS equals to 25 plus 25. Then our final answer equals to 50 degrees. All right, now let's do number 2. And feel free to pause this video so that way you can work on the problem and then you can come back and double check to make sure your answer is correct. All right, so let's go ahead and do number 2. All right, number 2. Again, we are given that point A is the incenter of triangle CDE, and we're asked to find these 3 angle measures. All right, so let's go ahead and go based on what's given to me. Since I know that point A is an incenter, I can conclude that CA, DA, and EA are angle bisectors. Okay, they're angle bisectors, and I know they're angle bisectors because angle bisectors create the incenter. All right, so since I have angle bisectors, I know that angle DCA is congruent to ECA. I know that angle CEA is congruent to angle DEA. And I know that angle EDA is congruent to angle CDA. Now I'm going to use that information to help me find for my missing measures. All right, so I know that this is 29 degrees, and I know this is 24 degrees. I know because of angle bisectors cut an angle in half, and therefore those angles are congruent. So now I can easily add in order to help me find the measures of DCE. DCE is this whole entire angle right here, which is 29 plus 29. So measure angle DCE equals to 58 degrees. All right, now let's go ahead and find the next angle, and the next angle is CDE. Okay, CDE. That's this whole angle right here. So in order to find the whole entire angle, let me highlight it. This whole angle right here, I'm going to use the bigger triangle. Okay, I'm going to use the angles of the big triangle. So meaning I'm going to use the 58. Okay, then I'm going to use this whole entire angle here, which is 24 plus 24, which is 48. I'm going to add those two together and subtract that from 180. So, and the reason I know that is because I know that measure angle CDE plus 58 plus 48 will equal to 180 degrees because all three angles in a triangle add up to 180. So I'm going to add these two. So measure angle CDE plus 106 equals to 180 degrees. Then to find the angle measure, I need to subtract 106. And that's going to give me that measure angle CDE equals to 74 degrees. Now lastly, let's go ahead and find angle DAE. And I'm going to highlight now the triangle that I will be using to help me find the measure of that angle. So I'm trying to find, and let me circle, or this angle right here. Okay, I'm trying to find that angle. So I'm going to use this triangle, and this is the reason why I'm going to use that triangle right there to help me find that angle measure. I know that this whole entire angle right here is 74 degrees. I know because I just found it to be 74 degrees. Since these two angles right here are congruent, I can divide 74 by 2 and give me the two angle measures. Okay, that's going to give me 37. So each of these angles are 37. And if you add them up, they'll give you 74. Since I have 2 out of the 3 angles, I'm going to add those 2 together and subtract that from 180 to help me find measure angle DAE. And I'm going to use the same reasoning because I know that measure angle DAE plus 37 plus 24 should equal to 180. All right, so that means I measure angle DAE plus 37, that will be 61, equals to 180. And then when I subtract both sides by 61 in order to solve for the angle, I get that measure angle DAE equals to 119. Okay, this is how we do problem number 2. Now let's do number 3. J is the circumcenter of triangle DEF. Find the length of FJ. Okay, so J is the circumcenter. Since J is a circumcenter, then I can conclude that GJ, HJ, and IJ are perpendicular bisectors. Okay, since they're perpendicular bisectors, I can notate that EG is congruent to FG, FH is congruent to DH, and EI is congruent to DI. And I can also conclude that I am given 90-degree angles because of the perpendicular part. Okay, the bisectors gives us a congruent segment, the perpendicular gives us a 90 degrees. Okay, now I'm going to try to do my best here and remind you of the properties of circumcenter. Okay, so a circumcenter, and it's not going to be the best, and that's okay, is the center of a circle. Okay, let's just take this off because it's not going to be transparent. And that is okay. Let me just do it this way then. Okay, it is the center of a circumscribed circle. Okay, I know it's not perfect, but that's okay. All right, that's as best as I can do. Therefore, since J is the center of the circle, then I know that FJ, DJ, and EJ are the radii of those circles. Thus, I can say that all of these right here, DJ, EJ, and FJ, are congruent to each other. So in order to solve or find the measure of FJ, I first need to find the value of x. And to find the value of x, I am going to set these two expressions equal to each other. So 8x minus 17 equals to 6x minus 7. All right, so I'm going to solve for x here. So I'm going to subtract both sides by 6x. Okay. Now I'm going to get 2x minus 17 equals to negative 7. Then add 17 to both sides. Okay, then we get 2x equals to 10. Then lastly, divide both sides by 2, and we get that x equals to 5. Now, this is not our final answer because the question is asking us to find the measure of fj. The reason why we found the value of x is so we can go back and plug it in here. So that means that fj equals to 6 times 5 minus 7. 6 times 5 is 30, and then minus 7, that gives us that fj equals to 23. All right, let's move on to number 4. S is the centroid of triangle LMN. Find each measure. So since S is a centroid, thus we can conclude that MR, PN, and LQ are medians. Okay, because the medians are the ones that construct the centroid. Therefore, since those segments are medians, the endpoints are vertex and midpoint. Therefore, since R is the midpoint of LN, I can say that LR is congruent to NR. Then I have vertex to midpoint. Since Q is the midpoint of MN, I can conclude that MQ is congruent to NQ. And since PN, vertex to midpoint, and since P is a midpoint of ML, I can conclude that MP is congruent to LP. All right, so now let's go ahead and find each measure. So just by looking at my diagram before I answer those questions, okay, since I know that Rn is 25, I can also conclude that Lr is also 25. If MQ is 21, therefore I can conclude that Qn is also 21 because they're congruent to each other. Since this whole entire segment or side is 58, I can divide 58 by 2. Okay, 58 divided by 2, that gives us 29. Therefore, that means that PM is 9, and so is LP. All right, so now let's go ahead and fill in our answers here. MN, we found that is 21 plus 21, which is 42, segment addition. Then LR, 25, and PM, we found that to be 29. Number 5. If Z is the centroid of triangle TUV, TZ equals to 60, XZ equals to 28, and WZ equals to 25. Find each missing measure. All right, so let's go ahead and fill in the information that is given to us here. All right, so I know that TZ, that's this part right here, it is 60. Now I also am given that XZ equals to 28. And lastly, I am given that WZ is 25. And we're going to find all of our missing information. So before I do that, since I know that Z is the centroid, in order to find our missing information, since we are giving information about medians, okay, I'm going to use the 2/3 rule. Okay, the 2/3 rule is from the vertex to centroid. It is 2/3 of the median. Okay, so that means that this is 2/3, this is 2/3, and this is 2/3 of its full median. All right, so let's go ahead and find our gaps here. Let's start with ZY. Okay, so since TZ is 60, that's 2/3 of the full median. Therefore, the remaining part is the 1/3. So to get from 2/3 to the 1/3, I have to divide by 2. So 60 divided by 2, that will give me 30. Now let's do the same concept for to find ZU. So to find ZU, since I'm given the 1/3 portion, in order to get to the 2/3, I have to multiply the 1/3, times 2. So that means 25 times 2. That will give us 50. Now lastly, to find ZV, I need to multiply again the 1/3 times 2 in order to get the 2/3 portion. Okay, so 28 times 2 will be 56. All right, so let's go ahead and find our information now. So ZV, we already found that, is 56. I don't know why I put down degrees. It's not degrees. Okay, this is length. All right. Then ZY, we found that to be 30. ZU, that's 50. TY, okay, TY is the full median. So 60 plus 30, that gives us 90. And then XV, okay, XV, that again is segment addition. So 28 plus 56, that will give us 84. Okay, this is how we do number 5. All right, let's classify each bolded segment here. All right. So for A, since we have 2 congruent angles, therefore this is an angle bisector. Next one. Since we have from the vertex straight down to the opposite side and it creates a 90-degree angle, this is an altitude. Okay. Next one. Since I have a segment that creates two congruent sides and a 90-degree angle, this is a perpendicular bisector. Okay, perpendicular bisector. And then lastly, since I have from the vertex straight down here, this point is a midpoint, and we know this is a midpoint since I have two congruent segments. Since I have two congruent segments, that is our midpoint. Therefore, this is a median. Okay, that is our median. All right, let's move on to number 7. Okay, for number 7, L, M, and N are midpoints of the sides of triangle PQR. Okay, so let's go ahead and label it. Since L is the midpoint of PQ, therefore PL is congruent to QL. If point M is the midpoint of QR, therefore QM is congruent to RM. And since M is the midpoint of PR, therefore PN is congruent to RN. Okay, so now let's go ahead and label our information that is given to us. All right, so we have that. Let me get a different color. Let's do pink. Okay, so we have that PR equals 246. We have that PQ is 40. And LN is 17. Find each measure. All right, so let's go ahead and find each measure. All right, so LM, okay, to find LM. Okay, so here, before I continue, I forgot to mention that these are mid-segments. Okay, we have mid-segments. Since the mid-segments connects two midpoints of two sides. So if you remember, mid-segment is parallel and half to its opposite side. Okay, it is parallel and half of its opposite side. So in order to find LM, okay, where LM, I have to divide PR, which is its opposite mid-segment or opposite side, by 2. So 46 divided by 2, that's going to give us 23. Okay, so this right here is 23. Then MN. Okay, I have to divide its opposite side by 2, which will give us 20. And then QR. Okay, I have to divide, multiply its opposite side or mid-segment by 2. So 17 times 2, that will give us 34. And then lastly, MR. Okay, MR is also going to be 17. Okay, each of these sides are congruent. So here's our more direct notation. And again, the scale factor from the small to the larger triangle is 2. All right, so now let's move on to our next problem, number 8. Which of the following, if any, are the orthocenter? If it's not an orthocenter, identify which center it is. All right, so let's do the first one. Okay, so the first one here, okay, we're inclined to say, yeah, they're altitudes, but remember the altitude starts from the vertex straight down to its opposite side. So in this particular case, yes, it is an orthocenter. And I forgot to mention, orthocenter is created by altitude. okay, by 3 altitudes intersecting. So here we do have the orthocenter since all 3 are altitudes. Here, again, we're inclined to say, okay, they are altitudes since we have a 90-degree angle, but if you look closely, since we have congruent notation for our sides, that indicates that this is actually perpendicular bisectors. Therefore, since these are perpendicular bisectors, all 3 intersect at a point that we call the circumcenter. Okay, so we have the circumcenter. Now the last one here, from the vertex straight down perpendicularly to the opposite side, we do have here 3 altitudes. Okay, and all the 3 altitudes do intersect at the orthocenter. Okay, so we have our labeled diagrams here. Now let's go on to the back. Let's go to number 9. Okay, we're going to construct the centroid. In order to construct a centroid, we need to construct medians. Okay, and I know we did this in class, but I'm still going to show you the first method that we did in class. And that is by constructing the medians. Okay, in order to construct the medians, the endpoints are vertex to the opposite side to its midpoint. So I need to find the midpoint of all 3 sides. So let's go ahead and label these sides. We have A, B, C. So I need to use the midpoint formula in order to find the midpoints of all 3 sides. All right, so let's go ahead and get the coordinate points for A, B, and C. So the coordinate points for A is -2, 5. Coordinate point for B is -5, -1. And the coordinate point for C, it is 4, 2. All right, so now let's go ahead and find the midpoints of all those 3 sides. And let me color code these so that way we know which is with which. All right, so let's start with AB. The midpoint of AB, okay, we have -2 plus -5 over 2. Then we have 5 plus -1 over 2. Okay, so we have -2 plus -5. Okay, so that's -2 minus 5. That's -7 over 2. Okay, so -7 over 2 gives us -3.5. Then we have 5 plus -1, so that's 5 minus 1 over 2 gives us -2. Okay, so the midpoint of AB is -3.5, -2. Or +2, excuse me, it is +2 since it's a +5, +2. Okay, so -3.5, +2. Okay, that's the midpoint of AB. Now let's find the midpoint of AC. Okay, of AC, we have -2 plus 4 over 2. Then we have 5 plus 2 over 2. Okay, and that we have -2 plus 4 is 2. And then 2 over 2 is 1. Then we have 5 plus 2 is 7. And then over 2 is 3.5. So the midpoint of AC is 1, 3.5. And then lastly for AB, or BC, excuse me, BC. Okay, midpoint of BC, we have -5 plus 4 over 2, and we have -1 plus 2 over 2. Okay, we have -5 plus 4 is -1, so we have -1 over 2. Then we have -1 plus 2, we have 1 over 2. So it is 0.5, 0.5. Oh, sorry. All right, so we have -0.5 right about here. All right, so again, to construct the medians is connecting the vertex to the midpoint. Okay, so let's go ahead and connect these points. So vertex to midpoint. And I couldn't match it. Vertex to midpoint. All right. Then we have vertex to midpoint. And then lastly, we have vertex to midpoint. And they all come together and intersect at this point. Okay, so the centroid has a coordinate points of -1, 2. And if you guys recall back in our notes, I gave you guys a fun little fact, and that fun little fact is that if you take the average of all 3x coordinate points of the triangle and the average of all the y coordinate points, it will give you the exact coordinate of the centroid. So let's do that. Okay, in order to find the coordinate point of x, I need to get all the x coordinate points. So that is -2 plus -5 plus 4, and since we have 3 numbers, and to find the average, I need to divide by the amount of numbers I'm adding. So therefore, we have -2 plus -5, that's -7, and then plus 4 is -3. Therefore, -3 over 3 gives us -1. And then we'll do the same thing for the y coordinate point. So I have 5 plus -1 plus 2 over 3. We have 5 plus -1, that's 4, and then plus 2, it's 6. And that gives us 2. So we get the same answer, which is -1, 2. Okay, here is our centroid. All right, then the last question is, how would you construct the circumcenter? In order to construct the circumcenter, I need to construct perpendicular bisectors. All right, so to construct perpendicular bisectors, I need to find the slope of all 3 sides. Okay, let me do that better. I need to find the slope of all 3 sides. Let's go ahead and label this again. We have A, B, and C. So let's go ahead and find the slope of AB. Okay, so we're going to do rice over run. Okay, so from this point to that other perfect point, I go 1, 2, and then 1 to the right. So 2 up and 1 to the right. The slope here is 2. Now the slope for BC, I'm going to find another perfect point here. Okay, 1, 2, 3 to the right, and then 1 up, rice over run. Okay, the slope here is 1 over 3. Okay, it is rise goes in the numerator, run, which is left to right, in the denominator. And then lastly, the slope for AC. Okay, I'm going to pick another perfect point. So A to 0, 4. Okay, I go rise, which is up or down. So it's down 1. 1, 2 to the right. Since I'm going down 1, it's -1. And since I'm going to the right, it's +2. So the slope here is -1 over 2. Now, that will help me find the perpendicular part. Now I need the bisector, and I'll explain how to get the perpendicular, but let's do the bisector first. I need to find the midpoint of all 3 sides. Okay, and it's the same triangle, so I'm just going to cheat a little bit and get the midpoints that we found from our previous answer. Okay, so the midpoint of AB was -3.52. Let me use this color here. The midpoint of AC was -0.5 and +0.5. And the midpoint of AC, it was 1 and 3.5. Okay, so in order to construct the perpendicular part, it has to be perfect. I need to write a perpendicular equation. So a perpendicular equation to this side, and to this side. So let's go ahead and draw a perpendicular bisector to AB. Since the slope of AB is positive 2, in order to get the perpendicular slope, it has to be the negative reciprocal. Okay, and the negative reciprocal is by negating it and flipping the fraction. All right. Since I have negative 1/2 to be the slope in order to be perpendicular, it has to go through a specific point. And that specific point has to be the midpoint, which is negative 3.52. So now let's go ahead and write our equation. So we're going to be using the point slope formula to help us write the equation. All right, so we have y minus y1 equals to the slope times x minus negative 3.5. So I have y minus 2 equals to negative 1/2. And let's go ahead and simplify the parentheses here part first. Okay, now let's go ahead and distribute. We get y minus 2 equals to negative 1/2 x minus 3.5 divided by 2. Let's see. 3.5 divided by 2, 1.75. Couldn't think on top of my head. There we go. Okay, now I need to move the 2 to the other side. Okay, that's going to give me y equals to negative 1 over 2x plus 1 point, I think is 1 point, or I don't know what I'm thinking, not 1 point, it is 0.25. Ooh, couldn't think. All right. So here is our equation for the perpendicular bisector for AB. All right, so we're just going to do this one, okay? So let's go ahead and plot this point. So I know that it goes through that point, okay? Since our slope is negative 1/2, I'm just going to start from that point, okay? It's going to be 1 down and 2 to the right. So 1 down, 1, 2 to the right, okay? So here would be another point, okay? Then I'm going to continue the pattern in order to draw my perpendicular bisector, okay? Now let me go ahead and connect the points here. That's the perpendicular bisector for AB. And I know it's 90 degrees because I wrote an equation in order to be 90 degrees. Let's actually find AC too. Let's go ahead and find AC. Okay, and I'm not going to do this whole part right here. I'm only going to find the slope. Okay, the slope for AC is negative 1/2. So in order to draw a perpendicular equation, it has to have a negative reciprocal slope. So the slope has to be 2. So let's do it the faster way in this time. Since my slope has to be 2, I'm going to use the rise over run. Okay, and the rise over run is going to be 2 over 1. So that means 2 up, 1 right. Okay, so from here, I go 2 up, 1 right. And now if I want to go the opposite direction, it is 2 down, 1 left. 2 down, 1 left. Okay. Here is the line. Okay, and I have my perpendicular bisector. And I can conclude that this segment right here is congruent to this one. This one is congruent to this one. All right. Now, lastly, let's just do it for BC. So since the slope for BC is 1/3, I have to do the negative reciprocal, which is -1/3. Okay, so for BC, excuse me, the slope has to be -3, or rice/1, -3/1. So that means I go down 3, right 1. Okay, so I'm going to start at the point, which is my midpoint. Okay, this is my midpoint here. So I'm going to go down 3, and since I don't have enough space, I'm going to go the other direction, which is up 3, left 1. So let's go ahead and plot that point right there. Up 3, left 1. Okay, and I think that's all the space that I have for the graph. Now let's connect those points here. And I have my perpendicular bisectors. There we have it. Now, just for the fun of it, okay, I want to construct the altitude. So let me go ahead and get a picture for the altitude. Okay, so I got the picture here. I want to construct an altitude, or the orthocenter. Okay, let's go ahead and construct an orthocenter. In order to construct the orthocenter, we still get the slope. So I'm just going to cheat again. Okay, we have A, B, C, and I'm going to get the slopes for all three that we found. So the slope for AB is 2. The slope for AC is -1/2, and the slope for BC was 1/3. Okay, so in order to construct the altitude, okay, which is for the orthocenter, okay, the endpoints is a vertex straight down to the opposite side, perpendicularly. So that means I have to construct perpendicular segments for BC, AC, and AB, and it has to go through each vertex. All right, so let's go ahead and find the negative reciprocals. Okay, negative reciprocal of AB, the slope for AB is -1/2. So I'm going to start at the vertice, which the opposite vertice for AB, I put A, which is actually C. Okay, so the opposite vertice will be at point C. Okay, so we'll go through AB, and it would also intersect at point C. So starting at point C, I'm going to do the rice/1, which is -1/2. So I go down 1, then I go right 2. But I want to go the other direction since I'm not going to be using this side over here. So that means I go up 1, left 2. Okay, up 1, left 2, and I continue the pattern. Okay. And that right here is the altitude for AB. Now let's find the altitude for BC. Okay, the altitude, not for BC, at point B, starting at point B. Okay, so that means that the slope, we have to use BAC, which has to be +2. Okay, so starting at point B, I'm going to use the rice/run, okay, which is 2/1. So starting at point B, we're going to go up 2, right 1, up 2, right 1, up 2, right 1. Okay, here's our altitude starting at vertex B. Now we started at vertex C, and we started at vertex B. Now let's start at vertex A. Okay, so we need to find the negative reciprocal slope of BC. Okay, which will have to be -3/1. Okay, so rise over run. So starting at point A, okay, I'm going to go down 3, right 1, down 3, right 1. So let's go ahead and do that. And this is what we get. Okay, let me actually use my straight edge this time. And here we go. And if I were to extend all of this right here, if you recall back to our notes and looking back at the GeoGebra, when we have a right triangle, they intersect at the vertex of the right triangle. Therefore, here we have a right triangle. Okay, and this is how we would construct an altitude. Now let's construct a mid-segment. Okay, because why not? Let's construct mid-segments. And remember, mid-segments is the only special segment that does not have a center or point of concurrency. So mid-segment. Okay, construct. And all of these are in a coordinate plane. Now, if this was just regular paper, obviously you can follow the same directions that we have done in the past. All right, so let's go ahead and label A, B, C. To construct a midsegment, the endpoints are midpoint to midpoint. So I need to find the midpoint of all 3 sides, and we've already done that. So I'm going to cheat again and find the midpoints. And here they are. Midpoint of AB is -3.52. Midpoint of AC was 3.5. And midpoint of BC, okay, is -1/2. -1/2. There we go. Now let's go ahead and construct the medians. Midpoint to midpoint, midpoint to midpoint, midpoint to midpoint. And there we have it. I know this last one is not perfect, but here we have our mid-segments. Angle bisectors is a little bit trickier to draw in a coordinate plane. Okay, so you won't necessarily know how to do it just yet because you will need the angle measures. But other than folding the segments in half, you won't necessarily quite know how to do it just yet. But we'll skip that one for now. All right, as always, if you have any questions or concerns, please feel free to reach out and I'll be more than happy to help.